All right, so we're going to go quickly through the concepts, and then I'm going to let you work on that review. And obviously, if you have questions from last week, I can answer those too. So the 313 and 314, which were on your quiz, thank you. 313 was graphing a point, so you could either be asked to graph the point, or if I gave you the graph, tell me what the point is. Okay, so just make sure you can read it in both directions. The review has both. Remember it's R and then theta, and then you would plot your point. Then it's going to ask you to give the additional representations, so you make sure that you know how to find the other ones between 0 and 2 pi. So if I want to find additional ones, you can either look at your graph. Some of you can just look at your graph and figure out what the other names are. But if you can't do that, then remember you can keep the R the same, take theta and add or subtract 2 pi from it, depending on what your angle is. If your initial angle is negative, you would add the 2 pi. If your initial angle is positive, you would subtract the 2 pi. Or you can change the sign on the R. God bless you. And then take theta and add and subtract pi. And that one you will always be able to do 2 of. So you should be able to get 3 additional representations of that coordinate point between negative 2 pi and positive 2 pi, which is what it will ask you for. Then we did the conversion between polar to rectangular, which is R cosine of theta and R sine of theta. Make sure you know your unit circle angles. Then you did rectangular or complex, imaginary, to polar. So if it's rectangular, it's x comma y. If it's complex, it's a plus bi. We find where it's located. So find your point, find the quadrant, because that's going to determine what theta is at the end. Then find, well, the order here doesn't matter, but you can find the tan of theta is the y over the x, or the b over the a, if you're in complex. And then theta is going to equal tan -1 of whatever that value is. And you're going to choose the choose the angle based on the original quadrant. Yep.
What if, when we get the tan theta, that number is
on your unit circle, then it's a typo. Like your quiz was? Yeah, no, it will be on there. If it wasn't, if you had your calculator, it doesn't have to be. But if you don't have your calculator, it has to be. Yeah. Nope. And then R equals the square root of x squared plus y squared, or R equals the square root of a squared plus b squared. And then you put it in R comma theta format. Questions on these? Make sure you understand how to plot the a plus bi. So if I gave you 2 minus 3i, I would know I go to the right 2 and I go down 3, and my imaginary point is there. Make sure you understand that stuff. This is your real axis. This is your imaginary. So some of these questions are going to be pretty straightforward, and then some of them, based on what you know about them, it's going to ask you information about it, okay?
For
Yep.
plotting 3i, you just go down 3.
Correct? Yep. So it could ask you about, the quadrant that point is in, something like that, instead of having you do it just, flat out plot it. Questions on 313? I'm going to give you back your quizzes tomorrow. Okay, if you know you're not going to be here tomorrow, let me know. I can even take a picture and send it to you, but I still have a couple makeups to give. Okay, 314 was all your polar graphs. You might be graphing by hand 1. Okay, it's not like the quiz where you had to do 3. But you need to know what they all are. So it could give you the equation and it could ask you, what do you know about this graph? A, it's a rose with this many petals. B, it's an inner loop limison with the max point of blank. Like it could ask you that kind of information. So I have if we have time to do it, I have is it a GIM kit? I think it's a GIM kit where it's just going to give you the question and then it's going to say like, what of these is it? Does it have symmetry to this? Does it have symmetry to this? Is it a convex limison? That kind of stuff. You would need to identify it just from the graph. And then obviously these came back again when we started to do our rate of change. Yeah, I will. Mm-hmm. All right, so let's do the circles. Okay, if it's f of theta equals a sine theta or f of theta equals a cosine theta. Okay, remember that symmetry, if it has sine, then it's symmetric to like the y-axis, right? Or pi over 2. And for cosine, it's symmetric to like the x-axis, which is called the polar axis. It's not going to use x-axis and y-axis. It's going to use polar and pi over 2. So if it's sine, where's your circle? Good. Above or below? So if it's a positive A, it's above. If it's a negative A, it's below. So if you understand that, you should be able to answer questions on that easy. If you don't understand it, then you got to plot it. Then you're wasting your time trying to figure out what it looks like. These are ones I would say it's definitely beneficial to just memorize where it would go. For a cosine theta, now it's right or left. If it's a positive A, it's to the right. If it's a negative A, it's on the left. Good on that one? If it asks for the zeros, you would set it equal to 0 and find where it's 0. Or it could come back in the one that we were just talking about, the one that you did in the homework with the little chart, the number line, and you plug in your values, and then you just look where you got 0. You could do it that way too. Then we did the limicons. Yeah.
Wait, so like what would the zeros be on like the circle?
So if it said 2 cosine theta, I would set it equal to 0. I would get cosine theta equals 0. And then the location where cosine is 0 is at pi over 2 or 3 pi over 2. You'd have to know if it went up or if it went down. Actually, they'd both give you 0. The graph is on the right. Yeah, so like this would be 2-ish cosine theta. The 0 is here, which would be at pi over 2 and 3 pi over 2. Yep. Good morning. Okay, so limicons, right? So what's the first one? Like, again, kind of to try to picture it in your head. That's what I do. What was the furthest left? Inner loop. And that's if what? A over B is less than 1. Then comes heart or cardioid. If it's open-ended, you can give me either one. But if it's multiple choice, you need to make sure you know cardioid is heart. And that's if... Good. A over B equals 1. Then comes dimpled. And that's if greater than 1 and less than 2. Good. And then the last one, convex, greater than or equal to 2. So, I mean, this might be an easy question in which you just get the equation and you pick from your multiple choice which one it is, okay? By way of an actual graph, like a picture of the graph, or it could give you the equation and it will literally ask you to identify the symmetry or the zeros or the, like, it could be any part of that. So make sure that you can do any part of it. Yep.
Like if you have like 6 minus 2, would that be like 3 or -3?
So 6, you ignore the signs. Always ignore the signs. So this would be absolute value of A, absolute value of B. Yep. And then remember, like, things that help you with this guy are that your max point is what? A plus B, okay? Your minimum point, or your minimum R, is A minus B. So the distance between them works both directions. Your symmetry, again, could help you knowing which direction it faces. If I know its sine, then my little inner loop or whatever is at the top or the bottom. If it's cosine, it's on the right or the left. If I wanted to figure out where the big part is, I can set the equation equal to your max. And then you find where your big rounded part is, and you know your loop or dimple or whatever happens opposite it. So those things can help you out. Yeah.
Also ignore the sign for the maximum.
Yes.
Okay.
Yep. Okay, then came Rose. And this is your, oh, I didn't write this equation up here. This is A plus or minus B cosine of theta, A plus or minus B sine of theta. So again, I know it's a limit on if it's something added. The rows is your multiple angles. So R of theta equals A sine n theta or A cosine n theta. If n is odd, then n number of petals. If n is even, then 2n number of petals. If it's even, in addition to whatever symmetry it originally has, it also is symmetric to the pole. So it could have x-axis, y-axis, or polar axis, pi over 2 axis, and pole symmetry. It could have all three of those if it's even. And to find your petal, set your function equal to R. And then negative R if you still don't know what it looks like. Again, this could come by way of multiple choice. Here's your options, figure out which one it is. Where you can even work backwards, plug in a point. Like, there's gonna be ways to figure it out using your symmetry, using your number of petals, using the length of the petal, right? A is the length of the petal. So there's not anything graphed by hand right now. You might have to graph it by hand to answer a question, but it is not full out, give me the full graph. Does that make sense? It's either a multiple choice question where you can figure it out from there, or it's or it could be, give me information about this graph in which you might have to graph it, not fully, but might have to graph it to understand it.
Gotcha.
Yeah.
What is negative?
It just tells you if your little inner loop is at the top or the bottom, or the right or the left. That's all. But you can find it by doing set it equal to the max. Yeah, I would say that's the easiest. Okay, then came like all the rate of change stuff.
Wait, are we not doing signs?
Nope. We'll go back to it when we do your, like, we're gonna go back and start doing the unit 3 review on AP Classroom. We'll review it, but I think it at max might be one question on your test. All right, so rate of change. This is rate of change. This is your increasing and decreasing behavior, increasing and decreasing distance from your pole, that kind of stuff. All that came in to the 315 lesson. So the question could be to identify if it's increasing, decreasing, if it's positive or negative, and then if the distance from the pole, or origin, I think is actually the word it uses, origin, is increasing, decreasing. So this will be similar to the one that was in your homework I think it was the last question. There's another practice one on your review where I'm going to give you a function and then you're going to get given a number line. I actually put the angles I want you to plug in. It is going to be from 0 to 2 pi, I think. And then you'll plug in your points and you'll figure out what the values are, and then you'll have to figure out, are they increasing and it'll say on the range, which ones are increasing, which ones are decreasing, which ones are positive, which ones are negative. You're going to give the intervals there where the zeros are. And then is the distance from the origin increasing or decreasing? So remember, if R is positive and it is increasing, then distance is increasing. So positive and going up, it's moving away from your pole. The distance is increasing. If R is positive and it is decreasing, the values are decreasing, then the distance from the pole is decreasing. You're getting closer to the origin. If R is negative, it's almost the other way around, because if R is negative, but the values are increasing, then the distance is decreasing. And if the values are decreasing, then the distance is increasing because you're moving further away from the origin. So you could see, like, I could give you a chart with these kinds of things and you could figure it out, or it could be based on the information that you are given or that you give. This is where you have to be really careful. Obviously, if you get these points wrong and you get the directions wrong, you're then going to get the increasing and decreasing wrong. I will probably consider that to be like a carry through error. So you'll lose the points on the beginning part where, like, if you put that it's decreasing and it should be increasing, you'll lose the points there. But I won't take the points again on the distance question because we'll call that I think they call that a carry through error. So if you mess up in the beginning, you lose the points at the beginning. But if you use that wrong, right, then you don't lose points again. Questions on those? All right, and then also in this was max min, your extrema. Okay, so you're looking for where your direction changes. If it goes from increasing to decreasing, then there's a max. If it goes from decreasing to increasing, then there's a minimum value. So if it goes up, comes back down again, max. If it goes down, comes back up again, min. And it could ask you, what is the max or the min? Like, what's the value of the max in which you would give the R value? Or it could ask you, where does it happen? And then you're giving the theta value. Questions on that? Yeah.
So you're going to give us that number line?
Yeah.
And you're going to tell us which ones?
Yeah. Mostly for selfish reasons, because otherwise you'll be all over the place and it will be the easiest way for me to grade it. Yeah. Okay, then comes the rate of change. So it could ask you for the rate of change from a chart. It could ask you for the rate of change from an equation. It could ask you from the rate of change from a graph, or where you'd have to like find those coordinate points, okay? So remember, it's f of the second minus f of the first over second minus first. And you will keep these answers exact. So if they have pi in them, they will keep pi in them. They could be weird. They could be like 2 over pi, 3 over pi, whatever. And then you'd have to compare them. So are they growing faster or slower? When we compare, we ignore the sign, because a negative rate of change and a positive rate of change, we don't care which direction they're going when you're comparing them, if that makes sense, right? If it's increasing by 2 over pi and it's decreasing, so it's a negative 2 over pi, the rate is actually the same speed. It's just a different direction. Does that make sense? So we ignore the sign. Yep. It says second minus first. Oh, that's first. And really, the order doesn't matter as long as you're consistent, but this is how we tend to do it. And then it could ask you to use the rate of change to predict. So whatever your rate of change is, let's say I got 2 angles, and then my rate of change was like, let's go with the 2 over pi, 2 over pi. And then it says find or use to predict f of pi over 2, for example. Then I'm going to take one of the values that are there, the one it's closest to. And I'm going to do f of, if it's bigger, then I'll do the, so let's say I had f of 3 pi over 4 up here. That was part of the 2 points I was given, right? Or I find it. Then I would do f of 3 pi over 4 minus f of pi over 2 over 3 pi over 4 minus pi over 2 equals 2 over pi.
So you said the average rate of change to the 2 over pi?
Correct. To whatever you get for the average rate of change. And then in this scenario, we don't know this one. We don't know f of pi over 2, but we would have found f of 3 pi over 4. We would actually have a value for that. So let's just say we use the original unit circle. Let's just say that 3 pi over 4, this would be negative root 2 over 2. It's not going to be that easy, but let's just say it's that. Over, I would find this, so this becomes 4. This becomes 2 pi over 4, and this is pi over 4 equals 2 over pi. And then I would multiply by pi over 4. I get negative root 2 over 2 minus x equals, this is 2 and this is gone, 1/2. I would add the root 2 over 2. Negative x would equal 1 plus root 2 over 2. And then change your sign. That would be your f of pi over, what do we do? 3 pi over 4. No, sorry, it was pi over 2. These are on your review. There's questions in, I think I gave you 2. So you have to first find, like, and this is a multiple part one. It's going to say find f, the rate of change. So you have to find, if I give you, so in this case, I gave you what? I said find the rate of, it would have been find the rate of change, average rate of change from, I gave you 3 pi over 4 is one of them. So let's say I did 2 pi over 3 to 3 pi over 4. So you would then find f of 2 pi over 3. You would find f of 3 pi over 4. And then you do your average rate of change. And then you do this whole setup with whatever it is you're trying to find. And one of them will be your unknowns. I would just change to x because it's annoying to have to keep writing f of whatever. set it equal to your average rate of change, and then multiply by the denominator, solve for x. And it will, again, you're not gonna have a calculator, so it's gonna be kept as exact. So it might be a really weird looking number, but it's fine. Yeah.
Is there gonna be any limit on?
No, it was a good review question because I think it might come up, but for the end behavior almost, no, yeah. Yeah, sure. Any other questions for content?
How many questions do you
How many questions? So right now it's 10. I think it will stay that way. But I do want to, I didn't time it all the way through, so I do want to make sure timing wise it's okay. All right. So the review is there. Obviously, that whole first page is your, wait, didn't I?